This technical short video is brought to you by Dave Kameen, VP of Marketing for JPS Interoperability Solutions. This video will cover the capabilities of the new Z2 controller. The versatile Z2 controller's browser-based GUI allows intuitive patching, monitoring, or dispatch to as many as 80 remote audio systems. This means you can have up to 40 dual-channel RSP-Z2s all in a wide area interoperability solution. Let's do an overview of the Z2 controller. JPS Interoperability Solutions has several decades of experience with voice communications interoperability, fielding their first devices in 1989. Over this time, the company has encountered and resolved the wide array of problems that can occur when disparate devices are patched together. The Z2 controller embodies that experience and creates a capable, wide area interoperability system, tying together the wide range of various voice communication devices interfaced to it remotely via dual-channel RSP-Z2s and other means. So let's discuss how the Z2 controller and the RSP-Z2 work together to create a wide area interoperability solution. Let's first refresh ourselves on how the RSP-Z2 works, and then we'll bring in the Z2 controller. The RSP-Z2 can be set in three basic configurations. The RSP-Z2 provides a pair of analog to IP channels along with a headset channel. The non-headset channels can be configured in multiple ways, best illustrated below by this partial screenshot from the configuration page of the unit's browser-based graphical user interface. The pictorial shows the three basic configurations. We'll talk about the basics of all three: independent pass-through, cross-connected, and cross-connected with backhaul. Let's discuss independent pass-through. This configuration provides two separate analog to IP converters. For each, active core on the analog side will send incoming audio out the IP backhaul interface and vice versa. Active core occurs when the channel determines that valid audio input has been detected. Available core types, methods of determining valid audio vary by channel type. The pictorial shows the two 4-wire audio ports on the right and the two IP backhaul ports with ROIP, SIP, or RTP protocols on the left. Backhaul options include RTP, SIP, which is BSI compliant, ROIP, the JPS proprietary radio over IP protocol, VIA for connection to the JPS VIA smartphone talk app, and bridge channels for applications when used in a system with other JPS devices. Note that, if desired, the analog channels can also be configured as either of the ROIP, RTP, or SIP channel types. This equates to a protocol converter. Now let's discuss cross-connected. This configuration patches the two analog interfaces together with no IP backhaul. When one of the two channels detects a valid audio input, the other will transmit this audio. See the block diagram. RSP-Z2 channel 01 is connected to a VHF repeater system for the State Highway Patrol, and channel 02 to the local fire department's 800 MHz trunk system. A channel talk group on each system is set aside for emergencies when the two agencies need to talk to each other. Whenever any user from either system transmits on the designated channel talk group, all other users on both channels can hear. Because the donor radios interface the radio systems identically to all other radios in either system, the RSP-Z2 installation has minimal impact. Now let's discuss the cross-connected with backhaul. This is a combination of the independent pass-through and cross-connected configuration. Only a single backhaul interface is needed because it is interfaced to the combined cross-connected audio of the two local channels. The diagram shows one of the many ways the backhaul channel can be used, as a SIP channel allowing a supervisor to dial in by a VoIP phone. All three channels are connected together, so the caller will hear anything in either channel, and the supervisor's speech will be retransmitted in both radio systems. The diagram shows the cross-connected with backhaul capabilities. When we look at this diagram, we can really look at it in a different way. So it's time to make sense of the information you have learned through this video. There is a not-so-secret word involved with the Z2 controller, the RSP-Z2, and even the soon-to-be-released ACU-Z1. This word and capabilities that make the Z2 controller and RSP-Z2 so dynamic is bridging channel. Let's make one point clear. The Z2 controller does not have analog audio ports like the RSP-Z2. The only but amazing thing the Z2 controller can do is connect RSP-Z2 resources, disconnect RSP-Z2 resources, monitor RSP-Z2 resources, and dispatch to RSP-Z2 resources. It does this by using bridging channels. With one Z2 controller and bridging channels, you can have an amazing wide area interoperability network of up to 40 RSP-Z2 units with 80 ports, all controlled by one Z2 controller, with full dispatch, control, and monitoring of any resource. Through the Z2 controller GUI, an operator can create interoperability nets by drag and drop operations on icons that represent each of the system endpoints that are interfaced by the RSP-Z2 unit. An operator can also perform dispatch operations on all endpoints. Icons can be individually set for full two-way communications or monitor only.